mystery item. This was put forward by Ed, who, if you could wave, Ed. I'll pass it around for the people in the room. Ed, what do you think it is?
I think it's like a transformer, but more complicated.
Uh-huh.
I'm wondering if it's somehow, I don't know, it does smoothing voltages or something, or if maybe there's an effect caused by having like AC currents going back and forward. I don't know.
But I think I know what it is, and it's quite a good mystery object because I jumped to a conclusion that it was one thing, but actually I think it's another thing.
An initial look, it looks like a transformer or something close to a transformer, but there's a little bit more going on.
No, it is a little bit more going on, isn't there? Because they're funny metal things on the side.
Yeah, that's the thing that's throwing me.
Yeah.
Like, what is that doing?
Yeah.
Any thoughts on Zoom?
It's quite heavy.
Yeah.
Looks like a bit of a tattoo gun.
Ah, okay.
I think it's an iron cord inductor, Matt.
Okay, we've got an iron cord inductor. We've got part of a tattoo gun, a possible transformer.
Yeah, the transformer with something else going on. It's not,
Yeah.
it's not basically on, but beyond that, I'm not sure.
If it was a transformer, it would have more than 2 wires on it.
Oh, yeah, good point.
That's got your in and your out, really, isn't it? Electromagnet.
Okay. It's roughly 3 inches cubed.
It's got terminals on each corner, isn't it?
No, it's only got 2 wires coming out of it.
Okay.
Okay.
Is that enough?
Right.
Switch the lights off, I think. Boy band Moody. Okay.
Yeah, so
Now, I wasn't absolutely sure, but I did think it was an inductor, as Bob said, and I think, Ed, you thought it was a transformer at first, but
it's only got
then you
one
went to
set of leads,
smoothing sort of componentry.
2 foils, 2 inductors.
So it is an inductor.
Ah, okay.
Okay, and I was so sure that it was an inductor, and I wasn't absolutely sure. And Bob, if you want to add or correct anything that I'm about to show, please do. I do like the water analogies for electronics, and the water circuit sort of analogy for an inductor is a water wheel with a large flywheel on it. So as the current starts to flow, there's a lot of resistance until it slowly builds up the rotational speed over time. And then when it gets up to full speed, there's practically no resistance. Then when the current stops, the inductor keeps the current going because the flywheel is draining its energy back into the current. So an inductor is an energy storage thing, just like a capacitor or battery is, but its storage is based on current rather than a voltage that a capacitor is storing a battery. These graphs at the bottom show that sort of smoothing effect that has. So you can see that if you apply a voltage, I'm at the edge of my explaining here. If you stick if you put that switch down, you put the voltage across the inductor, the current slowly levels out to the maximum level, and then it slowly ramps down when you move the switch back to B, which is open circuit.
Just giving you current smoothing then.
Yeah, a bit of a timing sort of thing going on there.
Inductors hate change, capacitors love it.
Excellent.
Yeah, that's the way to think about it.
So what I'm showing on the slide here, I've just handed around that blue circuit board there, and that's a power boost thing. So
Show it again.
these kind of lipo battery things. These are standard, like 3.7 volts, but to power something like an Arduino or something, it's you need 5 volts. So that this little circuit boosts the voltage up to from 3.7 to 5 volts. But I've showed it here because that 6R8, or is it GR? I don't know, it's backwards anyway. That component there on the board is also an inductor as well, which is the sort of
I think we've more commonly seen
inductor, yeah. And this diagram on the right shows a range of different inductors that are out there. So good question, Ed.
This large square.
It's the one with 3 characters on it. It's is it GR8? I think it is 6R8 maybe. I feel quite lucky that I guessed that it was an inductor and I didn't totally embarrass myself. But is this legible for anyone?
Mm-hmm.
Can you see the circuits?
Yeah.
The question is, what happens when the switch is closed on each of these 3 circuits? The first one is an inductor.
The lamp will turn on and then go to dim because the resistance offered by the inductor will fade away. So it's very high resistance at first, and then the current will begin to flow through that circuit and go around a lamp.
Gotcha.
Yeah, so the lamp comes on and then fades.
Yeah.
So that's A. That's okay. B.
And the lamp is
The other way round.
Yeah.
And
So
so
the
the other way round means that the bulb, you flick the switch and the lamp brightens up
Yeah.
slowly. And C.
They'll stay the same, but the current will be shared between the lamps. So it depends on the resistance of the lamps.
Well, there's a bit of a gotcha. It does C switches on instantaneously, but the value of the resistor doesn't make a difference to the brightness of the lamp because it's in parallel. Always gets 12 volts or whatever volts. Yeah, it's 12 volts, isn't it? So 2.5 out of 3. And there we go.
But that would be for an ideal battery.
So, excellent.
If you've got an ideal battery, I'll buy it off you.
And it doesn't include any capacitance or inductance of the circuit itself either.
Ideal wires as well, that's nice.
Yeah.
No, okay, I won't.
Okay, and that is the end of the mystery object.